Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Color Coordinated, I can't speak right now, Color Coordinated Differences by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have the 2 digits on an arrow give the coordinates of a particular target cell somewhere in the grid. The digit on the arrow's shaft indicates the target's cell's row, and the digit on the arrowhead indicates the target cell's column. The difference between the 2 digits should be placed into the target cell, and no 2 arrows target the same cell. Okay. So for example, if this was to be like, say, 7 and 5, that means this would be the row of the target cell, which would be 7, and this would be the column of the target cell, which would be 5. So this would be the target cell, and it would have to contain the difference between the 2 digits, which would be 2. So if this was 7 and 5, that would force this to be the target cell here, because that's row 7, column 5, and then that would contain the difference between those 2 cells, and that would have to be 2. And no 2 target cells no 2 arrows target the same cell. So you could not have, say, another 7 and 5 here. That would not be allowed. Also, a pink arrow contains 2 consecutive digits. So these must, if, for example, this was a 6, this would have to be 5 or 7 to be consecutive on the pink arrows. And for the green arrows, a green arrow, so the pink arrow basically acts like a white crop key dot. The green arrow acts like a whisper 5 line, because for a green arrow, it contains 2 digits with a difference of at least 5. So for example, if this were, say, 3, this would have to be 8 or 9, because those are the only digits which are 5 or more away from 3. And on a black arrow, one digit is double the other. So these black arrows are considered black crop key dots. So for example, if this was, say, a 2, this would have to be a 1 or 4 to maintain the 1 to 2 ratio between them. That's pretty cool. It's basically, yeah, this basically is very similar to a lot of traditional rule sets, but it just adds a coordinated difference between them. A coordinated, right. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, what do we have here? Well, we know for... Oh, this is going to be interesting. For all the black arrows, they can only have 1, 2, 2, 4, 4, 8, or 3, 6 as their coordinates. How many coordinates can you have? So 1, 2, 1, 2, 2, 4, 4, 8, and 3, 6. So you have 4 plus you have the reverse, right? You have 2, 1. So you have 1-2, 2-1. And they would both have to be 1. So only 1 out of those 2 can be there. So that's 7 then possible arrows. We have 1, 2, 3, 4, 5, and 6. 2 and 4. So 2 and 4 and 4 and 2, which could be 2. But both of those could be satisfied. 3 and 6, or 3 and 6, and 6 and 3, both can be satisfied. And we have 4 and 8, and 8 and 4. But if you have 4 and 8, that would have to have a difference of 4. And 4 cannot be next to two unique digits on a Whisper 5 line. And it would essentially be next to two unique digits here on a Whisper 5 line. So that's not possible. So we know the exact amounts of coordinated, we know the exact target cells. We have to have 1 out of 1, 2, or 2, 1. So 1 out of 1, 2, or 2, 1 has to be a 1. Oh, that's interesting. And the interesting part is, if this is 1, that has to be a 2. But then that's saying that that difference, 1 and 2, would have to be here, which would be 1. And that would be a contradiction. So this can never be 1, which means this has to be the 1. So this is 1, and it has to have a 1 to 2 ratio of 1 to 2, which says that in row 1, column 2, the 1, there has to be a difference of 1, which is there. So that's there. We do not have any more 1, 2s. We have to have 2, 4, 4, 2, 3, 6, and 6, 3. And then the last one is 8 and 4. It cannot be 4 and 8 again because of the reason that I talked about. And then that gives us 6 arrows, black arrow coordinates, because none of the arrows can be in duplicate situations. So this is either 4 and 8, or sorry, it would have to be 8 and 4. Okay, so 8 and 4 has to be correct. We have to have 4 and 2 be correct. So we have 1, 2 already set. We have 2, 4 must be 2. 4, 2 must be 2, because that's the difference between them. 3, 6 must be 3, and 3, 6, and 6, 3 must be 3. Then we have 8 and 4 has to be 4. So this has to be 2 and 4 here, because otherwise there's no other, we already have the 2, 1 that we've already counted for, and that's the only one we can have. So this has to be 2 and 4. This cannot be 2 and 4, it must be 3 and 6 in some combination. This cannot be 2, 1, 4, 8, or 2, 4, so this must be 3 and 6. Therefore, this must be 3, and this must be 6. So this is row 6 in column 3, which means this must be row 3 in column 6 there. This then has to be the 8 and 4 to match this cell here. So this one's done. We have 2 and 1 pointing to that cell. We have 4 and 2 pointing to this cell here. 3 and 6, row 3, column 6 points to that cell. 6 and 3, row 6, column 3 points to that cell. And 8 and 4. This is 1 and 2. Okay, so this has to be 4 and 2 here. Oh, wait, this could be 2. Okay, so this has to be, so we know this is 4, and this has to be 2 or 8 here, and 2 or 8 here. Okay. So again, row 1, column 2 has to have a difference of 1, so that's satisfied. Row 4, column 2 is pointing there. Row 3, column 6 is pointing here. Row 6, column 3 is pointing here. And we have one of these is 2 and 8. So we're going to mark this as A and B. So they have to be different ones. So 2 pointing to 4 would be here. And 8 pointing to 4, or 8 pointing to 4 is here. So those are all satisfied. 3 can only be next to 8 or 9 on a Whisper 5 line, which could be next to... This is unique digit. So row 3, column 8 or 9 must have 5 or 6, depending, relatively speaking. 8 and 9 here. Oh, wait, this doesn't have to be... Okay, this is not necessarily connected. This is connected, though, to these two. But these are not connected here. One of these is low, though. So you could have 4, 9. Okay. Where's 2 in column? Sorry, row 3. It has to be here. 2 in column 3 has to also be here, too. This is 2 or 8, 2 or 8. Whereas 4 in row 9, it has to be one of those 3. 4 in column 6 has to be one of those 3. And then 3 in column 5 has to be one of those 3. 3 in column 8. Sorry, row 4. I don't know what I was thinking there. That was weird. So this cannot be 3. Can't be 4. Can't be 6. So this has to be 1, no 2, 3, 7, 8, 9. These digits are consecutive. So are these. Remaining digits in box 1. We have 4, 5, 7, 8, 9, and obviously 4 can't be here because of the 4 in the row. What else do we have? These all represent 1s. Where are the 1s possible? Okay, so 3 and 2 is not possible. 2 and 1 is already set. So we have 3 and 2 is not possible. 4 and 3 is. So where are the possible 1s here? I guess we'll mark those as blue. 1, 1. Wait, that's not right. It would have to be 4 and so 2 and 1, 3 and 2, 4 and 3. Okay, so 4 and 3. Obviously not 5 and 4, but 4 and 5 works. 6 and 5. 7 and 6. 8 and 7. And 9 and 8. We have 1 already set. These could be 1, 2, 3, 4, 5, 6. And there are 5 consecutive arrows. So we don't have all those values. But yeah. If we had 1, 2, 3, 4 here, that would eliminate all possibilities for 1 in this central box. So that's interesting. That means we're at least guaranteed, we are guaranteed only 1 which has to have an 8, obviously. So this is 8 and 7 or 9 and 8 here. So we have 9 and 7, or, sorry, 8 and 7 or 9 and 8. One out of, you can have at most 1 out of 5, 6, and 4, 5. This could be 3, 4 here. One of these has to be 1 or 4. We're not sure which. These are in the same row. These are in the same column. Does that tell us anything? Maybe. I don't know. Where's 3 in row 1? It has to be one of these 3. So, again, if we had all 4 of these, actually, if we had just these 3, 1, 2, 3, that would eliminate all blue cells here, and therefore we would have to have that cell there. If one of these, okay, if one of these 3 is a 1, then it would eliminate the other one here, and therefore this would have to be a targeted cell. So either way, this is a targeted cell. So 4 and then 3 has to be a targeted cell. No, 3 then 4. 3 then 4. This can't be 3 then 4. This could be 3 then 4. So could this. So could this. That's not helpful. Okay. So what are the possibilities then for the, we know for certain we have 3, 4. We have one of these 2, right? So either 4, 3 or 4, 5. So we definitely have 3 and 4. 3, 4. We have 1 out of 4, 3. So 4 with 3 or 5. We have 1 out of 6, 5 or 6, 7. 6, 5 or 6, 7. And then we have 1 out of 5, 6 or 7, 6. So 5, 7 with 6. Okay, so those are the possibilities, or the ones we know for certain. And then we have another one with 8 for the consecutive digits. So we have a guaranteed 3, 4. The only ones that can be 3, 4 are here. So we could have 3, 4 here, 3, 4 here, or 3, 4 here. We have 4 with 3, 5. So this can't be either. This could be 4, 3, 5, 4, 3, 5. This cannot be 4, 3, 5. This cannot be 4, 3, 5 because we have a 3 in the row. Okay, so we have in these spaces twice. We have 6 twice. Okay, that's interesting. So again, we have 3 and 4, definite. So 3, 4 can be there, 3, 4 can be there, or 3, 4 can be there. We have 4 with 3 or 5. We're not sure which. This could be 4 with 3 or 5. This could be 4 with 3 or 5. This cannot be, and this cannot be. And this cannot. Well, okay, 4 and 5 could... No, 4 can't be here. So this could be 4 and 5. So this could be 3 and 4. Three, 4 could be here, cannot be here because of a 3 in the row. Could be here, cannot be here because of 3 in the box. 4 with 3 or 5 cannot be here because of 4 in the box. Cannot be here because of 4 in the box. But it could be 4, 3, 5. Actually, it would have to be 4 and 5 here. Or this is 4 and 5. Or this could be 4, 3, 5. Okay, then we have 6 with 5 or 7. 6 cannot be here. So this can't be 6 with 5 or 7. This could be 6 with 5 or 7. This could be 6 with 5 or 7. This could be 6 with 5 or 7. And this cannot be. Okay. Then we have 5 or 7 with 6. 5 or 7 with 6. Or 5 or 7 with 6, right? So obviously it can't be here. Could be here. 5 or 7 with 6. It could be here. 5 or 7 with 6. Could be here. 5, 7 with 6. It cannot be here. And then the last one is 8 with 7 or 9. So 7, 8, 8, 9, 7, 8, 8, 9, 7, 8, 8, 9, 7, 8, 8, 9, 7, 8, 8, 9. Okay. Does that tell us very much? Not particularly. Hmm. Okay. One thing that does tell us is, though, 1 cannot be any of these. So 1 has to be one of these 4. The Whisper 5 parts aren't going to be as restricted. Anyways, this digit cannot be 2, 8, or 4. So this is 1, 3. Cannot be 5, because 5 can't be on a Whisper 5 line. 6, 7, or 9 here. This can't be 1. Because we know for sure the 1 in this box has to be one of these 4. We know 1 has to be here. Okay, this has to be 1. Okay, that's good to know, too. That means remaining digits in column 4 are 5, 7, 8, 9. 1 has to be one of these 2. Oh. In row 4, 1 has to be one of... It cannot be here. So this is ruled out. So that means this, to equate to all of these, this has to be a targeted cell and is 1, which eliminates targeted cells here because they would both have to be 1, which means this has to be a 1 in a targeted cell, and this is 1 in a targeted cell. So this is 1, 1, and 1. That eliminates 1 from being there. This can't be 1. So now, Okay, now we can redo the pink stuff. We have 3, 4, and 4, 3. The only places for that... Okay, so 3, 4 could be here. So 3, 4, and 4, 3 could be here. This could be 3, 4, but not 4, 3. This can't be either. This could be 3, 4, but... and not 4, 3. Oh. Wait, no, this can't be 4, 3. Where is the only place which can be 4, 3 then? This can't be 4, 3. This cannot be 4, 3 because that would have a duplicate 3 in row 5. This can't be 4, 3 because duplicate 3 there. And this can't be 4, 3. So this must be 4 and 3 here. Which means, so this is pointing here. This cannot be 3, 4 anymore. Where is the only possibility for 3, 4? So this can't be 3. This can't be 3. That means this has to be 3 here. This has to be 3 and 4 then. This is the only 3 or 4 possible now. This can't be 3 again. We have 4 and 3, which is here, and 3 and 4, which is here. We have to have 6 and 5. This can't be 6, 5. This can't be 6, 5. So this must be 6 and 5 here. And then this is 7, 6. This can't be 7, 6, so this must be 7 and 6 here. And the remaining ones, then, this has to have an 8. So it has to be 8 here, which means this can't be 8. This is 2 and 4, and this has to be 8 and 4 here. Well, this can't be 7 or 8 because of 7 in the column and 8 in the box. So this is a 5, 9 pair, which eliminates 5, 9 in the rest of the column. This can't be 5, 9, or 7. This is 8, which means this can't be 7 because it has to be 5 away from 3. And it can't be 8. This must be 9. So row 3, column 9 has to be a 6, which is a difference of 9 and 3. This then has to be 1 because there's no other low digits in column 9 available. And so this can't be a 1 here. So we have 1 and 9 has to be an 8. So this is 8. This can't be 3 or 6. So this is 7 or 9. So something 1, which means column 1, has to be, it cannot be 5 or 9, can't be 6 or 8, this has to be 7 and 1. So row 7, column 1 has to be a 6, which is the difference between 7 and 1. We have 1 here, and this could be 6, 7, 8, or 9. No 4, 7, 8 here. This becomes a 5, 9 pair in row 1. Remaining digits of box 2 are 5, 8, 9. This cannot be 8. Where is the 8 in box 2 then? It has to be here. That means this cannot be 8 here. Okay. This has to be 8. It cannot be with 9. So it has to be with 7. So it has to be row 8, column 7. So this is 8 and 7 here. Which means this is a difference of 1. So this is a pointed to cell. So this is 1. Okay, so we have 1, 2 pointing here, row 1, column 2, 3, 7, 6 pointing to a 1, 4, 3 pointing to 1, 3, 6 pointing to 3, 4, 2 pointing to 2. We don't know what that is. Cannot be 1, 9, though, because we know, again, they can't point to the same digit. We already have 1, 9. So 1, row 1, column 9, row 3, column 9 are both pointed to. Row 6, column 5. Row 8, column 7. This is row 2. So row 6, column... So row 3 pointing to 9 already has one. So row 3 pointing to 8 has to have one. Which means this cannot be 8. This can't be 8. So row 3, column 8 points to a 5. So this is 5, which forces this to be 2. 5 eliminates 5 here, so this is 9, which eliminates 9 here. So it's 5 and 9. This cannot be 5 or 9 anymore. We have a 4, 7, 8 triplet, which eliminates 4, 7, 8 in the rest of the box. This can't be 7 or 9, so this is 5. So 3 and 8 is pointed to. Okay, so we have, this is done. 1, 2 points to here. 7, 6 points to here. 4, 3 points to a 1 here. 3, 6 points to 3 here. 4, 2 points to 2 here. 1 we don't know. We have 3, 9 pointing to 6. 1, 9 pointing to 8. 6, 5 pointing to 1. 3, 8 pointing to 5. 6, 3. So 6 and 3 pointing to 3. 3, 4 pointing to 1. 8, 7 pointing to 1. 2, 4 pointing to 2. 7, 1 pointing to 6. This cannot be 9, 1. This has to be 6, 1 here. So 6 and 1 pointing to 5. And then we have 8 and 4 pointing to 4. So we still have this one and this one. Okay. This has to be 2 because it cannot be 1, 3, or 4 because of 1, 3, or 4 in the box or the column. So this has to be 2. So 7 and 2 would make this a 5, but that's not possible. So this has to be 9, 2, which forces that to be a 7. So this is 9, 2, which points there and is forcing that to be 7. That leaves the remaining digit in column 9 as a 5. That leaves this as a 1, 9 pair. 9 cannot be here because of 9 in the column, so that's 1, that's 9. We cannot have 1, 6, wait. 1 and 6 could point to a 5. 1 and 7 cannot point to 6, so this must be 1 and 6, which points to there. So we have all the pointers done, and then now the rest is just basically normal Sudoku. We have 4, 5, and 7 remaining in row 4. This can't be 4 because of 4 in the box, so 4 has to be here, which makes this a 5, 7 pair. 5 can't be here because 5 in the column, so that's 7, that's 5. Remaining digit in column 5 is a 2. Remaining digit in box 5 is a 9. Remaining digit in column 6 is a 2. That means this cannot be 2 here. 2 cannot be here because of 2 in the row. Where is a 2 in column 3 then? It has to be here. So this is 2. This cannot be 4 because of 4 in the column. This can't be 4. Remaining digits in row 5. We have 4 and 7. 4 can't be here because of 4 in the box, so that's 7, which makes that 4. That leaves this as a 9. 7 eliminates 7 here, so this is 8, which eliminates 8 in the rest of the box. Column 7. We have what? 3 and 7 remaining. This can't be 3 because of 3 in the row, so this is 7 here and 3 here. Remaining digits in column 8. We have 6 and 8. This can't be 6 because of 6 in the row, so this is 8, that's 6. Remaining digits in row 7 are 5 and 9. 9 can't be here because of 9 in the row, so this is 5 and 9, which makes this 5. Remaining digits in column 1. We have 1 and 9. 1 can't be here because of 1 in the row, so this is 9 and 1. Remaining digits in row 9. We have 4 and 7. This becomes a 4-7 pair. Remaining digits in row 8. We have 3 and 8. This can't be 8 because of 8 in the column, so this is 3, this is 8. Ew. Okay, what have we not done? Okay, 1, 2 points. So how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 targets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So then what about these? Three, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 9. Oh, it's 9 and 2. Wait, why couldn't it have been 7 and 2? Oh, I think I went to the wrong one there. Hold up. So that was a mistake. Row 7, column 2 could be a 5. Okay, so that is a problem. Huh. So I did it the wrong one here. I was saying that's row 2, column 7. So that looks like it's the answer, but let's try to actually get it there. Remaining digits in row 2 are 1, 7, 9. This can't be 1. This becomes a 7, 9 pair. This can't be 7 or 9. So this must be 1, which means this can't be 1 here. We have a 7, 9 pair in column 9. So this can't be 7 or 9. So this is 5. This has to be 2 because of what the remaining digit in box 8 has to be. That leaves this as 2, 5 here. This can't be 2 because of 2 in the row, so this is 5, that's 2. And we have 7, 9 remaining here. This can't be 9 because of the 9 in the row. So this is 7, that's 9. That leaves this is 4, and this is 4 here. This has to be a 6, 7 pair. 6 cannot be here because of 6 in the column. So that's 7, which makes this 6, that makes this 9. This can't be 4, 7, so it's 8, which eliminates 8 here. Remaining digits in column 1 are 1 and 9. This can't be 1 because of 1 in the row, so this must be 9, which makes this 1. None of these can be 2, so this is all the same. That forces this to be 2 here. Remaining digits in column 8, again, are 6 and 8. This can't be 6 because of 6 in the row, so this is 8 and 6. Remaining digits in row 8 are 3 and 8. This can't be 8 because of 8 in the column, so this is 3, this is 8. Remaining digits in column 7, we have 3, 7, and 9. And this can't be 3 because of 3 in the row, so this must be 3 here, which makes this 7 or 9. And we have 5, 7, and 9 remaining in row 7. This can't be 9, so this is 5 or 7 remaining. And we have 4, 5, and 7 remaining in row 9. And this can't be 5 because of 5 in the column. Okay. That's interesting. So if this is 7 and 2, that means this has to be a 5. if this is 7 and 2, that means this is 5. This would have to be not 7, so it would have to be 4. Oh, that'd be contradiction. 7 and 2 forces this to be 5, which forces this to be a 4-7 pair, which eliminates the 7 here. That's why this can't be 7. So therefore we know this is 9 and 2, which forces that. So therefore this must be 7 here. So this is 7, which makes this 4, this 5, this 4, that's 7. 9 eliminates 9 here, so it's 5 and 9. 9 eliminates 9 here, so it's 7 and 9, and this must be 7. Kind of a mistake for this part, this specific part, but fortunately I caught that early enough. Or I guess it was late, because we were basically almost already done with the puzzle. But, I would probably put this at challenging level. It's not quite easy. It's in between easy and challenging. But again, I like to err on the side of grading things a little harder than they probably are, instead of grading them easier and surprising people with how hard it is. But anyways, a cool little puzzle. And I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.